All right. So in terms of announcements for today, exam 2 is on Thursday, and you will receive emails about like your start time, just like we did in exam 1. So we have staggered start times, given we don't want to give a lot of load on somebody, right? So you'll receive that email soon. Again, it's a 90 minutes test. Everything is covered until the last lecture, which is lecture 16. So lecture 17 is not covered, of course. But of course, like lecture 16 was about dictionaries, how to create them, how to access elements in them, not looping through them. Although we did a lecture exercise where you were supposed to loop through that, and most likely you got the idea. But anyways, I'm not testing on like looping as much because we'll look at that today. The second thing is that we will have a review session during lecture time on Thursday, just like as always. And I'll go over the practice material that I posted already. Although I've also posted the solutions, but if there are questions, there are doubts, please bring them and we can answer them on Thursday. So Thursday is like an optional, I would say, review session. If you feel that you want to spend more time like preparing for the exam yourself, you don't have to join it. Again, I'll go over like if you have doubts, you can ask questions and like the practice material itself. All right, so having said that, let's begin with lecture 17, which is dictionaries part 2. So what we're doing today is that, again, we are looking at dictionaries from the perspective of like what all we can do with that information that's stored in a dictionary. Because if you remember, by definition, dictionaries are like bag of values. There is no sequence. And so it's like an extension of sets, but we have a key value pair. So we can access values through keys. And why is that more helpful? That's because like values can take any Python object type. And keys have certain restrictions, if you remember, but values can be anything. And then we can even save like a list of values or like strings or anything else, including dictionaries and sets. And so that's what we're going to see today through like the IMDb example, where we'll create dictionaries of like string and set pairs, which means string will be the key and set will be the value. And then we'll also understand how to convert dictionaries, like how to convert like from one key to another. And finally, we'll understand combining information from many dictionaries. Also, we're looking at dictionary of dictionaries. That means like nested dictionaries, which is what this attribute value pair is talking about. Of course, we'll go through an example and a little bit about how to access APIs and getting data back as a dictionary. So that's like referring to like the JSON format. And that's like a dictionary, and then we can use it as a Python dictionary. All right. So let's look at this example where we are trying to compare lists with dictionaries. And let me just like copy this example. So I have this list and a dictionary. And by structure, if we look at them, this, right? So if by structure we look at them, now this list is a sequence of values, right? So let me create it. And dictionary is also like, of course, a bag of values, but it has these keys that are like linking the key to the value, right? So let me create this as well. So what I'm doing here is if I'm trying to access the values, let's say in the list option, I'm trying to access, let's say, B, right? So I'll just say list option, the name of the list and the position of that element. So I'll just say like list option 1, and I'll access B. Now in the dictionary option, uh, dict option, again, I'm trying to access B. And so I'll just say dictionary option and the key is 1 and give me B. All right, so they like seem very similar. And again, let's look at another example where I'm trying to update these two. So in terms of the update, the way I can update my list is like simply go ahead and assign that value to that index. So here, if I just do like list option 1, assign it D, right? And then let's check what list option looks like, right? So this is like A, D, C. If I do the same to a dictionary, I think we discussed this a little bit last time. If I do the same, because there are like these keys that have to be unique. So like currently in my dictionary option, the value for the key 1 is B. but if I'm trying to go and update it explicitly with a D, let's say, let's see what happens. Let me try to find out what's there in the dictionary option. Well, it did get updated, and as we discussed last time, it gets updated with a more recent key value because we cannot have these keys as like repeated elements. These are unique. So I can go and update the key value pair by simply going and assigning it a new value, and it will take the most recent value. All right. Now let's try to extend the definition of dictionaries to list as well, where let's say I'm adding a key value pair. And so I'm saying uh, dictionary option, add this key value pair. Spelling is option. And let's say I'm asking it to go and add this like key value pair E. Okay, and let's execute this and go and check what's there in my dictionary option. And of course, I have this key value pair because I just added it there. All right. If we try to do somewhat similar to my list, all right, list option at position 10. Do you think this is correct and this is going to work? Do you think this is like, okay, if I go and update at position 10, add E? Let's see. I'm not seeing anybody answer. Vaskar, you're saying no because it's not unique. So you're saying like 10 is not unique? Huey, you're saying no, but why no is my question. Exactly. So Huey, you're right. This index is not there in the list, right? So let's see. Okay, here. So list assignment index out of range, which means I'm assigning it to list index 10. But if you're looking at the list option, I don't have 10 elements. So I can only assign an element to an existing sequential value, right? And even when we do something like this, like if I do a list option and just remove this, and when I do a dot append, there is a sequential addition of these values in the sense that if I'm doing like list option dot append E, it will add to the next available sequence, which is like 0, 1, 2, 3. So this element E will be added at position 3 and not at position 10. So here is the fundamental difference between dictionaries and lists. In dictionaries, keys could be anything hashable. We need not maintain this sequence of values, which we are doing in lists. And because they can be anything hashable, that's why we are like, we have this option of accessing them directly. We don't have to like sequentially go to each and every element like we do in lists and access something. We just like go and pick that key, whatever that key is, and that key could be 100. I don't have to like wait for 100 elements to fill in my bag until I add this 100th element. I can just like go ahead and add it, right? And so here's the fundamental difference between dictionaries and lists. In dictionaries, we don't have this sequential addition. We don't have these sequential um, way of storing elements, but in list we have it, right? So that's what this example here is showing us. Yeah, we can access them in a similar way, we can update them in a similar way, but we cannot extend them in a similar way because in lists, the way addition or extension happens is that like we are sequentially adding values. We cannot just like go ahead and add any like position and a value, right? But we can definitely do that in a dictionary. All right, let's look at this another dictionary and try to like do a few things with this. So here, this is again showing us that like keys can be anything hashable, and hashable meaning things that cannot be updated. For example, strings are the most popular ones. Usually we use strings as keys, but tuples can be used, booleans, integers, and floating points can also be used. But mostly we use this. And if you remember from the previous lecture, so I won't repeat this, here, like this is how we access any element in my dictionary, right? The name of the dictionary, square brackets, and then the key value, and it's going to give you the value of that key. All right, let's look at this one where, and let's try to further understand this one. Okay. All right, so here, this dictionary has keys as the names of people, or I don't know, whatever, and like strings essentially. And then the elements that are values are sets of values, right? And we saw one such example last time as well, but now we are trying to understand it more from the perspective of using these things in a loop. So let's look at this. For example, I create this dictionary. I know how to access values. So for example, if I do a D2 and the key here, right, it is going to give me this set. So that is clear. Now, sometimes we only need keys, if you remember, right? And so there was a way of getting keys. There was this method. So we said d2 dot keys. This is going to give you like only the keys that are there. And this object is a dictionary key type object, which we don't know how to work with. So usually when we are using like this, the output of this dot keys or dot values, we use like this list typecasting kind of a thing so that we get the list of the names. All right. Now, how to loop directly over a dictionary? Of course, you've seen that before, but there are many ways of doing it. The most common way or the most usual way is that you just like write for some variable, right? So for some I in D2. So if I'm writing for I in D2, by default, this I will be considered as the key. Okay, so let me show you what I mean. So this I will be the key. And if you want to access the values, then again, name the dictionary and then access it just like you've been accessing when using indices in lists, right? So for I in D2, I by default will be the key. And if you're trying to access the value, just like use that to access the value, use the key to access the value, right? So for instance here, let's see what it prints. Right, so it printed I first, which was my name or that string, and then it printed the value, which was like D2 I, because that's how I index it. Again, you can also use other ways of like directly say that you're just like only interested in keys and not values. So these are just like alternate ways. This is the most generic way, and I like to use it this way because you can both access the keys and the values this way. But you can do directly like d2 dot keys. Let's say you just like want to iterate over only d2 dot keys or d2 dot values, 2 dot values, or you can even do d2 dot items. And I would leave that in as an exercise to find out what exactly does it print. And let's actually see here. Let me actually show you this items. Don't clearly remember if this was it. And just like let's print this I. Let's see what this I gives us, right? When we are saying for I, and I don't think we'll have a bracket there. All right, so this is what we'll get, like the key value pairs as they are, like in these tuples sort of way, right? So you'll get like the key and the value. If you want to use it like that, you can directly use dot items, or like the way I like to use it is like I know how to access every element, so I'd rather just like go ahead and do for I in dictionary, for iterable in like for variable in my dictionary, print I or dictionary square bracket I. All right. So those are some of the ways of those are some of the ways. Yeah, Linus, I already showed you how to print it without the brackets. So those are tuples, not really brackets. So you can like consider them tuples, and you know how to take out values from tuples, right? So that's one way. But like the most default way would be like this. Like always use your like loop through the dictionary using for variable in dictionary, and then you can do anything with it, right? So this is like the most common way. You won't get tuples. You don't have to worry about getting things out of the tuples. So those are some of the alternate ways I would say, but this is like the most common one. All right, so that's how to begin working with loops. Let me see if I missed anything. Okay, so we already talked about this. Yeah, and so you can do d2.keys, as I said, d2.values or d2.items. Each one of them is fine. But again, like my preference is this, but this is the easiest way of looping through a dictionary. All right, a little bit about copying and aliasing in dictionaries. And let's look at this example to better understand that if a dictionary is a part of a list, then some of the rules that applied earlier and like basically the idea of dot copy still exists. So if you're creating a shallow copy versus a deep copy, just like in lists, the same idea exists here. So for that, we'll like to demonstrate that, let's look at this example first. So let's begin by creating this dictionary. So D equals dictionary, and okay. Now I'm going to add some values in this, and then I'll add this dictionary to a list, right? So let's say I'm adding key as 15 and value as some string, right? So we haven't looked at this as such an example before where we were using keys as integers, but of course you know that we can. So that's what we're doing here. And I just create a list, right? And okay. And the whole purpose of like putting these dictionaries in a list is not because of the list structure, but because we want to see what are the differences that exist between like a true copy versus like an alias. So that's what we're doing here. So when I do L dot append and D, this is like this dictionary only. So this is like an alias for this dictionary because I'm just like using it directly. So L dot append, let me show you what L has, first of all. Right, so it's a list which has this dictionary that has like a single value. And now if I like outside this list, right, if I go and update my dictionary, the changes will be reflected in the dictionary that's saved inside my list L because it's just acting as an alias to that. And I'll show you what we need to do when we really want to create a copy, right? So let me first do this. I'm adding another key value pair to my D. And to be consistent with the text, the lecture, all right. So let's look at L. First, let's look at D. So D obviously has this. Let's look at L. So now L, we appended this D to L, right? And so that D and this D, they are both pointing to the same object. It is the same object, right? So the changes are reflected here as well. Now, let me show you if you really wanted a true copy, because sometimes you might want a true copy and you want to like make some changes to that true copy only and not this one, right? So for that, what we should do, and again, I'm going to append that true copy to this so that we can like look at the changes side by side, right? So L dot append D dot copy, right? So if I do like if I explicitly go ahead and append D dot copy, that means it's saying go and append a copy of D, but then if I make changes to D, they will not be reflected in the copy, only in the alias, right? So let me show you what I'm doing right now. So for now, my L has obviously both the dictionaries because I just like created a copy of whatever D was, and they just like appended it to my list, right? But now will be this like the changes that we make will be interesting because let's see whether the changes are reflected in both of them or none of them or like one of them, right? And what changes are reflected in what. So now this is going to be interesting. Let me go and add, or maybe let me go and update this 15 key value pair, right? So let me go and update D 15. Instead of hi, let's say hello, right? And that's fine. Let me check what L has, right? Now here is the interesting part. And of course, as expected, so one of them was an alias to my original D where I'm making the changes. The other one was a copy when like all these changes were done and I created a copy. So then that becomes an object in its own, just like we talked about like objects versus aliases in lists. It's the same thing with dictionaries, except like here now, this was the true copy, which means like whatever changes I make to the original object will not be reflected in my true copy because that's an object in itself. So you'll have to like go and access that and do something if you want to. But whatever changes you're making to D, and this is just like a demonstration. This is not like like solving some problem. For example, let me show you again. If you remember, removing the elements in dictionaries is done by DEL. So DEL 20, let's say I'm trying to remove this D20. And why am I interested in that is because this D20, right, is in both of the like the copy and the alias. So let's see what happens. All right. And L is this. Why? Because my D is this, which is like my which this is the same object, this and this. Both of them are the same object, but this is my copy. And so the copy again does not seem to have any of the changes. It's not seem to be affected by any of the changes that are happening in the original object, because this is an object in itself. And again, like I know I'm repeating many times, but like whenever your code has such a requirement where you need this dictionary object, but then you want to make like different changes to that one, make sure that you're creating a copy and not an alias, because this might get confusing. Or just like go and create a new object, for example, then that's fine, but make sure that you're not creating an alias. All right, so this is what this is talking about, copying and aliasing dictionaries, which is like, of course, the result was a little bit surprising, but not quite, because we do understand the difference between aliasing and like true copy, right? So alias is sometimes also referred to as shallow copy. So if you come across that, then like know that I'm talking about an alias. And a true copy or a full copy is sometimes also known as a deep copy. So if you come across that word deep copy, then know that I'm talking about like a true copy or a full copy. Okay. All right, so a few things to just like check, and maybe you can like create your own lists and dictionary objects and try doing these things like assigning lists between sets and between dictionaries. So this is like basically saying between sets and between dictionaries. We already saw between dictionaries. So similar kind of thing will exist with sets as well, right? So that's all this is saying. Right, so I won't stop for the first lecture exercise. Let's actually move on because we have a lot to cover today. Uh, okay, so again, jumping back to our favorite IMDb example that we have looked at multiple times until now. But today we are looking at it from two different perspectives. So essentially trying to answer two different questions. The first question that we look at is, we know that like we have looked at this file and I have it open here. I have the Hanks file open here, and the same actor, for example, Tom Hanks, right, is like listed for the same movie again and again, The Polar Express, as you can see, like Tom Hanks. So there is a like a repetition of these values, right? And the problem that we're trying to look at, right, is that who was involved in the most different movies? Because if I go and like keep counting these lines for every actor, that is not going to give me like who was involved in the most different movies, because like the same actor could have like be there in the file multiple number of times for the same movie, right? So this is the question that we're looking at, and what we'll do is we'll again like work with the same IMDb file to sort of figure out how we can do that. So like a high level idea is I'll create a dictionary, right, where I'll have the actor name as the key, and I'll create a set of values. And why is that so useful? Well, if you remember, sets will allow only unique values, right? So for example, when I come to Tom Hanks, right, and I start adding the like movies in the set, like no matter how many number of times this Polar Express appears, it will be added once to the value. So when it's added once to the value, then I can go and scan through the dictionary one more time to find out who was the busiest, because like who's like name like who is associated with the most number of movies. So I'll have sets associated with every actor name. I can simply go and check the length of those sets. So whoever has the max, I'll say, okay, this is the actor who appeared in the most number of movies, right? So let's start building that. Any questions so far about anything? Oh, I'm sorry, Rochelle, I didn't see your question. How would you make changes to the copied dictionary? Yeah, that's an excellent question. So here, as I said, like in the end, that go and create another object, like maybe assign it to some variable and then go and make changes to that. Because here you just like said, go and create a copy. So maybe like pick that up. In this example, it's not quite evident, but one way to have like dealt with that is I would have created like, let's say, x equals d dot copy, right? And then X would be the one where I'll be making the changes, right? So this was just like a demonstration to show you like what's happening where. And so the list is the best way of like showing you that. All right. So where was I? Okay, yeah, to converting like first let's like write a solution to this one where we are trying to create actors as keys and sets of movies as values, right? So let me start. I think I copied the same code from the previous lecture. Yes, here. So this is something that we know. Here I'm going to read the name of the file, print the name of the file. Well, this is optional, just from the perspective of like, okay. And here what I'm doing, like starting from this line, line number 16, is I'm creating an empty dictionary called movies, and then go through every line in the file that I open, split by this separator, right? We know that this is a separator, and we know that like the name of the actor is at position 0, right? In every line, the name of the actor is at position 0, and what else? Name of the movie is at position 1, right? So that's all I'm extracting here, which is why I'm not repeating. This is something that we've seen before. So now we'll do something starting from here, right? All I'll do is I'll create like this dictionary, or in fact, like populate this dictionary rather, because I already have that dictionary created with the name of the actor and the movie added in the set of values, right? I hope everybody is clear with what we are trying to do. And let me actually show you what I'm trying to do before we move on, because I know this can get a little confused. What I'm trying to do is like I'll have name I get, I'll have the name pointing to a set, right? So movie 1, movie 2, and so on will be added here, right? So that's what I'm reading in here. And why is this like important to have it as a set? Because if I had it as a list, then movie 1, it's repeated multiple times, it will be added again and again. And so sets will take care of the fact that like I don't need to take care of like if a movie is repeated, I don't have to do an if else or anything like that, right? My set is going to take care of that. So let's try doing that. Now it's pretty straightforward. If name, and because name is the key, right? So I'm checking if name is in movies, then that's good. Just go and add the movie name, right? So movies at name, right? Movies at name dot add, right? And if like you're not understanding anything, just like feel free to drop in your question in the chat and we can go over that again, right? Because this is really important to understand right now. Now, if the name exists, go and add this movie to that name because that name is my key. Otherwise, if it does not exist, go and create this like new whatever it is, right? So this new is going to be this movie's name. Go and create this new key value pair where my value is going to be an empty set first, and then in that empty set, I'm going to add like the same thing. All right. Okay, so that's it. And like, of course, we have to figure out who is the busiest. So I'll have to go and loop through this dictionary, but let's see if this dictionary is created correctly or not, right? So this is how you should always test your code. And so what I'm doing here is, let me do the Hanks file, right? Hanks file is the best way of testing your code as, all right. So here, this looks okay to me. For example, Jim Hanks and the set of movies, okay? And then Colin Hanks and the set of movies, Tom Hanks, and notice like Polar Express will be obviously um, like be there once and not repeated because this is a set and this is what we wanted, right? Now let's say I'm given this dictionary. So this is like another set of problems that you can see like going forward either on the exams or on the homeworks, is that you've created this dictionary and go and do something with it. So for example, loop through this and like go through this dictionary and see how many actor, like who is that actor who was the busiest. So the actor with whom the most number of unique movies were associated, right? And maybe also find out who are the actors who just like appeared once. So then maybe the set of movies was just like one, right? So let's look at how we can do that because we haven't really looked into like detail of how to loop through a dictionary. And so today we are going to do that. And the way I'm going to like write this solution is I'm keeping track of who appeared the most number of times and who appeared just once. So I'm keeping track of both. Let's say that was the problem. If that wasn't the problem, then you can get rid of like this who appeared once. So that's up to us. And so I'm keeping track of singlets where I'm like just checking who appeared once, right? And so this is like just like a counter. So I'm initializing it here. And then who appeared the most number of times? So again, another counter that will keep track of the most number of movies. All right. Now, the way we said we can loop through the dictionaries, like the most common way is like for some variable in my dictionary. So for name in movies, all right? Now, once I go inside, and this is very important to understand, what exactly do we require? Now, if I go inside my movies dictionary, for example, here, right, I have this, my name is going to be the key, right? And every time I iterate through like every element that I pick up from here, I have to go and check the length of this, right? This is the count of the movies for this actor. So that's what I'm going to keep it in a variable and then compare it with my singlets and my most. And based on this count, I'm going to update my most and my singlets, right? So that's what I'm doing here. So let's say I have a variable called movie count or movie CT to be short, and just go and check the length of the set, right? And how will I get the length of that set? How can I access the set in the loop? Can somebody tell me here? Movie and name. Huey, you're right. Yeah. So this is important. That's why I just like wanted to pause for a minute and ask you guys. Excellent. So Kiran, you're also right. Movies and then name. So of course, name was the key, right? And then dictionary is like movies. So movies and name. This is how we're going to access that. Now that's it. I have the length of the movies for the first actor. So I will go and check if the movie count is one. Because if it is one, then it goes into that singlets list. Because that's the counter for how many people appeared in just one movie. And if it's greater than most, right, then my most needs to get updated, right? So both of the if statements will be here. And because they're not like mutually exclusive statements, I'll have like two if statements essentially. So movie count equals one. If that is exactly equal to one, then I'll just update that singlets counter. Okay, so plus equals one. Oops, it's not what I named it. All right. The other if is going to be if my movie count is greater than most, right? If it is greater than most, then I have to go and update my most equals uh, movie count. All right, so I'll get like the number of people who appeared in just like one movie, and I'll also get like the most movie count. But then maybe I'm missing something, and that something is that I also want to keep track of that actor who appeared in that movie that has the biggest, sorry, the set that had the most number of movies essentially. So in order to keep track of that, I'll also have like another variable that gets populated within this if only, right? That is going to be person equals name because I know name is the key and that's the name of the person, right? And let's go out and print this. So print, maybe I'll do a dot format. This person appears most often, and we can even like say these many number of times, right? And dot format. Okay, so who is that person? That person is, of course, in the variable person. And then most will have like these many number of times, and maybe how many people appear just once. So print uh, these many people appear once. All right. Dot format and singlets, of course. Okay, why is this code so important? This is important because now we are understanding that this is not just like reading something from the file and creating a dictionary, but rather going over that dictionary, so looping through that dictionary, right? And then getting some outputs. For example, let's look at this part, right? So Tom Hanks appeared most often, that is like 35 times, and 9 people appear just once. And this was in the Hanks file. Of course, in the IMDb file, this is going to be different. Um, and again, like I'm repeating this thing that this was like a demonstration of how we can uh, utilize a dictionary that was created because we know how to create a dictionary from a file now, right? But now once the dictionary is created, it has a lot of information. We can extract different types of information. In fact, there's a nice exercise that's given in the lecture notes that talks about like asking you to go and extract different information, different pieces of information from the same dictionary. Because once the dictionary is created, you have access to a lot of things. All right, so let's go back to here. All right. So the second section, of course, is that we want to convert one dictionary to another, right? For example, here I just like found out who was that busiest individual. So I just like kept updating this. This is the standard way of finding a max or a min, right? And so I just like kept updating this variable here and then finding who was the busiest, right? Let's assume we are interested in finding the n busiest individuals. Like let's say in the IMDb file, I am interested in finding the top 10 or the top 25 busiest individuals, right? And based on the number of different movies they are involved in. Now I know that I have that information, right? And I can utilize that information to get this, but there could be like different ways of solving this problem. And one way that we are looking at, and there is a reason why we are looking at this particular solution, and that's because we want you, like we also want to demonstrate how can we convert like from one dictionary to another. So that's the whole point of like kind of showing you why we are doing it. So what exactly we'll do is we'll go through this movies dictionary, which we already created, of course, right? And what we'll do is for every actor, we will calculate how many movies they were associated with, like by taking the length of the set, of course. And then this length will be the key in my new dictionary that I'm calling actors. Let me actually, again, before writing the code, demonstrate, because then that itself becomes confusing. Because now I have to find, like, let's say top 10 actors, right? So top 10 actors. And one way of finding it is, how about we have like a dictionary where we have like, let's say these keys are numbers. So like number 2, and then it tells me, okay, actor 1, sorry, actor 2, and so on, like who all appeared in just like 2 movies. And then maybe like who all appeared in like 10 movies, right? And so I'll know that these are the people who appeared in like these many movies. And so like based on whatever key values I have, I can sort these keys somehow, right? So I'll have, let's say, I don't know, like whatever numbers I get. And then based on that, right, from highest to lowest, let's say I'll sort this new dictionary from like these number of movies to the highest, or from the most to the lowest, whatever. And then print out the top 25 actors by the number of movies they are associated with. Of course, you can say that there can be an issue here, which you can like totally figure out. Let's say I was interested in top 5 actors, right? And let's say there were like these people that were associated with 10 movies and 12 movies, right? And so there were like 2 actors here, right, in 12 movies. And let's say there were 4 actors here, right? And let's say this is my entire edition, and there were like other, there was nothing else, right? And trying to find out top 5 actors, and I have like 6 actors here. So of course, with my solution, I will have to print all 6 because I know that these 4 also appeared in like in movies, right? So that is a slight sort of issue with that solution, but this is the best we can come up with because I cannot discard anyone who actually appeared in 10 movies, right? Because of course I'm looking at top 5, but that person also counts as top 5 in a certain way, although these are like top 6. So that is a small issue with this solution, of course. But then we have to consider people who are like tie, like there is a tie, if there is a tie essentially, right? So we have to consider those people as well. And so I wouldn't say that's an issue, rather, because there is no other way of like, why is actor 1 here? Let's say there was an actor 3 and an actor 4, right? And both did 10 movies. So that I don't have like any explanation of like why I shouldn't put actor 3 or why I should put actor 4. So that's why I'm including all of them. All right. So let's do that. Let's begin with that. But the whole point is not to get those top 10 or top 25. The whole point is how to like build one dictionary and then using that dictionary build another one. That's the focus of this particular problem. And I'm just going to copy this part because this is nothing new. In fact, this part into another file. Here, let me just remove this comment. It's taking up a lot of. Okay, so this we know that the movies exist, right? And let's maybe create it with the Hanks file. Um, Okay, so that's created. Now using this dictionary, we already know how this dictionary looks like. I'm going to create an actors dictionary. So I'm beginning with actors equals an empty dictionary, right? And what I have to do is loop through the movies. So for name in movies, right? Uh, Again, get the count, movie count, if you remember, because why? That count is going to become my key. And then using that count, I'm going to put every actor that comes in as like in my set, which is my value, right? So that's exactly what I'm going to do. Okay, for some reason. Okay. So again, I'm taking out movie count just like we did last time. So this is like a building on what we did earlier, right? LEN movies and not like this. We know how to access the values. So that here. All right. So how am I going to create a new uh, like dictionary? Again, the overall structure stays the same. Just go and check, right? If it's not in like the actors dictionary, then go and create that key value pair. If it exists, just like go and append or add or whatever, right? So like there could be multiple ways of doing it. Let's say we are creating a list, right? So here we can create a list if you think about it. We don't necessarily need to create a set of the names of the actors. We can also create a list. Can anybody tell me why we can create a list here? Like the key is the number of movies and the value is the list of the names of the actors. Why can we create lists and there's no need for a set anymore? Huey, you're saying actor name are all unique from the previous dictionary. Excellent. Yes. So that's the idea here, right? I already have, right, like these actor names that are there in my dictionary that are like, they are already unique. So there is no need for a set. Maybe if you like, just go and create a set. Otherwise, I'm fine even like by using a list, right? And so that's what I'm going to do. Just like to show you some variability in the way we can solve different problems, let's create a list because we've seen like how to do a set, right? So let's create a list. And I'm just like flipping this if statement, although we could have done the same thing here. So I'm just flipping it. I'm saying if movie count, and the whole purpose of flipping it to show you another way. That's it. Otherwise, there is nothing special happening here. So if movie count not in actors, right? Then go and create it, right? It's the same thing that was in else, essentially, right? So what I'm going to do is actors and then movie count. Okay, my WebEx is throwing some message saying that my connection is, I don't know what, like this is a big message. So if for some reason I get disconnected, just like please stay there. I'll try to come back as soon as I can, just to let you know. Okay, so here I'm creating like movie count, which is a number associated with a list. And all I have to do is actors and then movie count. Because this is a list, just go and append that name, right? So dot append name, right? And else, again, as I said, I just flipped it. Otherwise, there's nothing special in this code. Actors, movie count, the same thing, dot append and name. All right. So first, let's try to understand what this actors dictionary has, right? And then we'll go to the sorting part where we'll just sort the keys because the keys are numbers, and then based from like highest to lowest, or maybe just like cap it at like 25, right? Just loop through that and cap it at 25. So that's all that's left, and I'm sure everybody can do that part, but I'm going to show you anyways, right? So print actors. All right, let's see what this has. Okay, so here it is. And again, with the hacks file, you can try with the IMDb. So we have like these numbers that are keys, right? And every number tells me that this is the, for example, look at this one, right? For one movie, there are like so many actors there until here, right? And then there's just like one with 35, and there are two, um, just one with two movies, and so on, right? So the number of movies is like my key, right? And who are the actors who appeared there? And so because I'm trying to find out who are the busiest individuals, right? What I'm going to do is I'm going to sort this dictionary, this actors dictionary, from highest, which is like the most number of movies, which in our case is 35, right? To the lowest, the least number of movies, and print out the top, let's say five. I don't know, top five is fine, right? By the number of movies they're associated with, right? Because this is a small one. Of course, with the IMDb, please like just like remove the 5 with the 25 and you will get that result. But I'm doing it for 5 because this is like a small dictionary. All right. So I'm creating this variable keys. And again, to show you that we can use this. And okay, let me first show you what we are doing here. Sorted and actors. And I don't know if you've tried this, reverse equals true. This is a parameter in the sorted function. For instance, if I'm not using it, this is what I get. Let's say sorted actors. So I get this list. Of course, you're aware that sorted always returns a list. And if you're using sorted with a dictionary, it returns a sorted list of the keys of your dictionary, right? So this is like my sorted actors. But because I'm like trying to find the n busiest individuals, so I have to like reverse this in the sense that, let me again show you, if I do a reverse equals true, and then yeah, of course. So then this will be reversed. Why? Because I'm interested in like this and not that, right? So that's what I'm doing here and putting it in a variable called keys. So reverse equals true and putting in it keys. And then I'm using a while loop to keep track of the count of like top 5, let's say, and printing them. That's all I'm doing here. So let me initialize my while loop. Of course, like this is one way of doing it. You don't have to stick to that. And this count is going to keep track of these like keys as such, right? Because if that exceeds your like count of 5, then you just like stop. And I is for the while loop. So I is like iterating over the while loop one at a time. So I is for that, count is for keeping track of the length of that value, right? So count equals 0. And then let me just like write a simple while loop here. Okay, so while count is less than or equal to 5 or 6, whatever we are interested in, let's say like as long as this is less than 6, and my I is less than len of, because I don't want to go beyond what that list has, that keys list has, right? So length of keys, because remember what keys has that number that is associated to some set of actors that appeared in those many number of movies. That's why we have to do an and here, right? Print, and we know what we want to print. So let's say keys I, the number, right? And in the dictionary, the name, right? So I'm fine with that. Actors, keys, I. Notice what I'm doing exactly here. What was keys? Keys was this list of my keys actually in my original dictionary. And so when I'm looping through this like while loop, I is my index for my loop. And so that's why I have to use that index here for like accessing the values in my actors dictionary. And this is like for like specific to my loop, because I'm saying keys I, meaning keys like 35, go and access the actor at 35, right? This is what this is saying. Then the next iteration, it'll be like keys and then 10. So go and access the actors in that dictionary that had the key value 10. And so like the values could be many of them, right? Which is why we'll do this thing. So that's the next step, because what I'm trying to say is if we go back and look at the dictionary, the same list can have like multiple actors, right? So I have to keep track of that. And so as I discussed earlier, either have the entire list there, right? Or just like stop wherever we are done with that count. This is the only way that we can deal with it. So count len actors and then keys I. All right. And then of course we need to update I because I is the loop variable. So I plus equals 1, right? Okay, so let's try printing this and see like who are the actors who are like top 5. So of course, like everything will be printed in this one. Let's like even reduce it because this is like because notice what's happening like 1, 2, 3, 4, 5. But now we are updating the count by the length that entire list because I have no way of like kind of getting rid of that. So maybe how about we do it for less than 5. So let's say I'm interested in top 4, right? Just to demonstrate because this will definitely be better with the IMDb. Uh, should be strictly less than maybe 3 is a better way of demonstrating this. Yeah, so top 3 because I have no way of like getting rid of uh you know what I'm trying to say, like getting rid of these actors because they were also there in that like whatever I'm trying to figure out. So of course that's the catch here, but of course that is included in the solution. But this is like one way of dealing with a problem that involves like the usage of a given dictionary, because you will see like going forward we will be using these given dictionaries more than often. We will There will be less emphasis on like creating a dictionary because you already know how to create it. There will be more emphasis on extract information from this dictionary and do this, right? All right, let's take questions. uh Rochelle, okay, fine. Any questions related to the overall idea of this, right? Just, I think the fundamental thing that you should remember always when working with dictionaries is how to access the elements. Once you clear on how to access the elements, I think you're good there. For example, we knew how to access like each of the elements and create like, let's say using those elements in movies. I know how to create a new dictionary. That's not that difficult. The important point is always, and I like to use it this way, always try to use this kind of a structure where like you're saying for variable in dictionary. This is always more like clear, I would say, rather than using the built-in methods like dot keys, dot items. Of course, that's an option. I'm not saying don't use it. If you feel comfortable, go ahead and use it. But I somehow like personally speaking, find this easier, better. So that's why we used it in like all the solutions today. All right, so here is that what I was talking about, and we usually leave it for the students to finish this because this is like an excellent way of going over like the two different approaches that we looked at. This is just like building on that. So basically, whatever we did in those two approaches, you can utilize that and solve these problems. For example, what movie involved the most people? What movie, if you remember the movies dictionary, let me just, so this is essentially asking you to go over like this one, print movies. Let me just print it. Okay. So here we have the movies dictionary that has like these actors as keys and movies as uh, values, right? But this is asking you to do something else. It is saying what movie involved the most people. So what do you think we need to do exactly here? What in order to answer this question? The most number of people. So anything, any that rings a bell? Your answer is for each value count actors. I think that's going to be. I mean, of course, that's a solution. But if you're like going and looping through this movies dictionary, right, and then counting the actors, of course you can do that. But then, how do you keep track of those movies? How do you keep track of like, let's say I'm keeping track of this one, Goofy Foot, right? And this appears multiple times. So how will I do that? And one way of doing that, and again, what you're saying is correct, just flip this, right? How about we create a dictionary where we have like the movie names as keys and actors as values, right? Either flip this using this dictionary itself, which is like my movies dictionary, right? Or another way is like directly read from the IMDb file, and instead of having like the name of the actor as the key, just flip these two, right? So instead of like name being here, have the name here and have the movie here. The exact same code, just take it take the exact same code, just flip like movie here and name here. So basically, I'll have the name of the movie as the key and the value as the set of actors, right? And so once I have that, then I can say which movie involved the most people. Because once I have that dictionary, I can do the exact same thing that we did in like the first problem that we looked at here, right? Have this most variable, go through that new dictionary, and then keep a track of that. So it's just like flipping it, essentially. Right. How many different people have been in movies that included Meryl Streep? So this is like a good one, where what we can do is you can use this like uh, this dictionary itself. So of course Meryl Streep is not there in Hank's like file, so we'll have to run it for the IMDb file. But regardless, let's say Meryl Streep obviously will be an actor, and then there will be the movie names, right? So what we can do in this one is like how many different people have been in movies with Meryl Streep. We have to go and loop through the dictionary, right? Keep checking and like maybe create a set of her movies, like take out the set of her movies and then loop through the dictionary and and find which movie names like appear in the values. And whenever a movie name appears, put this in a set, right? And let me like show you high level for this one as well. And I really want everybody to go and try those because these are nothing but like we already looked at this high level two different problems, and all of these problems can be solved just by using these approaches. So for instance, for this Meryl Streep problem, one way, of course, is to first of all like create maybe a list of Meryl Streep movies, right? So create a list of Meryl Streep movies, right? And using this list, right, you can go and loop through the movies dictionary, right? So loop through movies dictionary, right? And whenever you find, like in one of the, so when you're looping through the movies dictionaries, you're doing like movies and whatever, like let's say name, right? And there is a set, right? So using this list, you can find out whether any of the elements are there in that set. If it is there, then maybe you create an empty set, which I'm calling set1, which is going to be my final output. Just go and append or go and add rather this name there. Why? Because like this actor appeared in that movie in which Meryl Streep was also there. All right. So that's one way of doing it. The other way is get the set of movies that Meryl Streep appeared in. Get that set, right? Again, loop through this movies dictionary and maybe try to overlap this set with that set, right? So maybe try to do an intersection. So if you see that intersection, the length of that intersection, if you see that the length of that intersection is not equal to 0, right? That means that person appeared with Meryl Streep, and so you get the name of that person. So add the name in the set1, right? So again, whatever we did until now, right, can be twisted, can be manipulated in a certain way to answer all these questions, right? For instance, there is another very interesting one. Solve the degrees of Kevin Bacon problem. Who has been in a movie with Kevin Bacon? These are degree 1. So maybe create sets, set 1, set 2, set 3, that will have like degree 1, degree 2, degree 3 individuals for Kevin Bacon. Using like this movies or the actors dictionary, whatever you've created, using that you can solve these problems. All right, I think I saw a question coming up. Leo, your question is there a reason why we should use sets instead of lists? Well, I think I talked about both, right? When I talked about the Meryl Streep solution, I talked about both. Either create a list or use the set as it is. Basically, we already have sets, right? We already have sets in my movies dictionary, so I'm not creating anything else. I already have a set, so either use it as a set or create a list of the movies, and then I think I showed both the solutions. Right, so going back to the degrees of Kevin Bacon problem, again, create a set. This is like the exact same as Meryl Streep, right? So this is doable. These two are really interesting. Who is not a degree 1 individual and has been in a movie with a person who was in a movie with Kevin Bacon? And these are degree 2 individuals. Again, this is not that difficult as it sounds, because here a hint is that you will be using some set operations that you looked at in the sets lecture. And the good thing is we already have our data in the form of sets. So you can directly apply those set operations. And of course, like going back to the Merrill Street problem, you can again apply the set operations there directly. As I said, like go and check the intersection, right? Right. So again, as I said, we usually leave these problems for the students because they are essentially building on the two different types of problems that we just looked at with the IMDb files. And essentially, you'll be just using those dictionaries that you already created. So please go and try these yourselves. And if you get stuck, come back, ask me during office hours, or go to any office hours and ask. But this is like a very good exercise for you to do. All right. The next important topic for today is attribute value pairs. And this attribute value pairs really utilizes the entire power of dictionaries, which we haven't looked at until now, which is like meaning we can create a dictionary of dictionaries. And because like dictionaries allow that kind of a structure, we can create these attribute value pairs in a way that like every dictionary within a dictionary can be regarded as an attribute value pair. So let me show you an example where we are considering the problem of representing all the houses that a real estate company is trying to sell. So why is this like an attribute value pair problem? That's because like you'll have like different houses, right? And every house will have some properties. For example, like what's the like maybe the number of bedrooms, the price, whether it has a pool or not, the style of the house, the age of the house, and so on, right? So if you think about it, like in my entire dictionary, I'll have these like houses, house one, house two, house three, and the information that each house points to is pretty much the same. And that's why I can create these attribute value pairs. Okay, so let me show you this example here. And I've already created this dictionary called houses, right? And as I said, right, houses has like house one. So the houses itself is a dictionary. And walk through this. Let me show you what I mean. Okay, so this houses in itself is a dictionary, right? So this is a big dictionary. But now we have like house one, house two. These are different values. Sorry, keys, right? So house one is a key, right? And then house two is a key, and so on. And you can see that these are also pointing to these dictionaries, right? So this starts here and ends here, right? Again, house two is starting at like this curly bracket starts here and ends here, right? And so every key is associated with a dictionary. So maybe dictionary one, dictionary two, and so on, right? So this bigger dictionary has like these key value pairs where the value itself is a dictionary. So first of all, such a structure is known as a nested dictionary. So that's like the first part. Okay. Now, the other thing is about attribute value pairs that I talked about, right? And that is used for storing data in like for problems like these, wherein we have some key that is like similar. For example, here I've stored information about houses. And how different can that be? That would be like really, really similar. Every house has certain attributes. The only difference that is there to every house is that maybe those attributes have different values. So what are those attributes? When we go inside this nested dictionary, we see that there is an ID, and then there is an address, and then there are a number of bedrooms, pools, style, prices. So all these are attributes. And this is a way of like saving data in a more structured and organized way in Python, where you have like these dictionaries that have attributes. And why we are calling them attributes? Because they're repeated. You don't have a different set of attributes here or a different set of attributes here. They are repeated everywhere. So they have like the exact same structure. And these are known as like attributes because they are repeated again and again in every value for every key, right? Now, the only difference that's there to these attributes is the values themselves. So obviously, house one will have a different address than house two and then house three, right? Similarly, bedrooms can be or may not be the same, can be different. So the values these attributes are taking can be different, right? And again, this is like one way, and this is very similar to the JSON format. That's why we use JSON formatted files a lot when we're working with Python, because they are like structured in a similar way as these attribute value pairs, or like a nested dictionary rather. So we can just like directly take the JSON file, use that library that we talked about, I think a couple of lectures ago, and simply load it as a dictionary or a nested dictionary. Because the only thing that's there for, and this is like so useful, because let's say I'm trying to store like user data somewhere, right? I can have like user one, user two, user three, their attributes and their values might differ. But uh, then that's fine, because I'm like really trying to uh, save this information for every, for example, house or for every user. All right. So why is this useful and how to use it? So for example, this is a nested dictionary, of course, right? And this is how we access it. So let me show you. First of all, this is similar to like we did with nested lists, right? If I do houses and then access house two, and I think I haven't created it. So let me first create it and then access it, right? The important point here is like, you should know how to access these values. So if I do houses and then house two, let me just, right? So I said houses, similar to how we access dictionaries, right? And then said, go and uh, go and fetch this uh, key. So that key points to a dictionary itself. So it just like returned that entire dictionary. But let's say I was interested in the price of this house. So I'll just like go ahead as it's shown here, right? I'll just go here and say houses. And then in house three, obviously it'll point to this dictionary. And then just like you access other dictionaries, just go in and access that. So for instance, I'll just go and say price, right? House three price, and I'll get that. Or if I want to say house three pool, right? So similar to that, I can access any attribute value pair. Why is this like important? This is important because now I can write code regardless of whatever data is there in my houses, as long as I know the structure. I don't care what those values are, because I can use those values, right? If I know that the structure of this dictionary is that there is like an ID, there is an address, there is a bedroom, there's a pool, style, and price, right? I know how to write my code. I know how to loop through this dictionary no matter how big this is, right? I can loop through houses, and while looping through houses, I can access like any of these elements, because I know that there is a specific structure to that. I know that the internal dictionary to which my keys are pointing to have a certain structure, and I can exploit that structure in my code. That's the whole point of showing you this attribute value pair in dictionaries or in specific nested dictionaries, right? So this is like in turn also demonstrating that you can have like a dictionary within a dictionary, and then maybe here you can have another dictionary. But then the way to access that would be that have another level of square brackets and then keep going inside, just like we did with like nested lists. All right, I think I saw a question, but it disappeared. Caesar, your question is what is JSON? We talked about like different file formats in one of the lectures. That's when we discussed a little bit about JSON. That's JavaScript object notation, but we don't have to go into the details of that. It's just like a file format. It's the way we store data, and it's very similar to a nested dictionary. That's why I mentioned that here, right? So if ever you come across like a JSON file, just know that it's like somewhat similar to a nested dictionary. Just that it's not a Python file, so we'll have to read in that and then just like simply load it as a Python dictionary. That's all. But again, there are libraries available for that, and I think one of the lecture notes also talked about that. Import JSON. You did do that. Import JSON somewhere and then loaded that data as a dictionary, right? So that's what JSON is. Okay, the next thing that we need to, like again, we have looked at how to access APIs, right? And APIs are nothing but application programming interfaces. And again, we are talking a little bit about them, and that's because we talked about this attribute value pair, we talked about JSON files, and we talked about like the structure of this attribute value pair. So again, that discussion of APIs comes back. This is nothing but like in simple terms, do not get like overwhelmed by this term API. These are special programs that help us get like external file information, right? And utilize that to convert them to Python objects, right? And why is this discussion coming in Python dictionaries? That's because most of this data, that external file data, is these days available in this JSON file format, which is like JavaScript object notation, as I just said, right? And the good thing is that there are libraries available in Python, and we are doing it here, of course, like import JSON, I forgot. So there are libraries available in Python. For example, this this JSON library that helps us load that data from external sources. Let's say there is a website, and then convert it to a dictionary type, right? And of course, this it's beyond the scope of this course to go and look at like very complex APIs, for example, getting Twitter data or Facebook data, right? All of those are like really complex because those are dynamic websites. That means like every second there is a change on the website, and so there are more complex APIs for that. We are not looking at that at all in this course. We are looking at these static APIs, like basically reading data from some static websites where there is some data, but it's not changing, right? But again, because this data is on the web, we need an API, and we have looked at this before, this one, URL lib.request, and this URL lib is essentially a library that helps us extract data from these static websites, right? And we have looked at this before. So again, we are looking at it from the when we were doing like reading in files, remember? Now we are doing it from the perspective of this JSON, and just like a demonstration to show you that this particular website, this website here, has some static data that is in the form of a JSON file. And we will show you that we can convert it to a Python dictionary type, or this like attribute value pair type. So I'm going to just like copy this code here. Again, there are rarely like any more static websites available these days. All are dynamic. But again, just like demonstrating that we can get access to that data and convert it to a Python object. So what this is doing is this is importing JSON. Once we read this data from that particular URL, right, this will help us like read the contents and then load as a JSON. So that's what this JSON.loads is going to do, whatever I read from that file. Because what I read is going to be text. But then this JSON.loads is going to convert it to like that JSON file will be converted to some Python object type, right? So the URL, again, I just want to copy this URL. Why? Because I hardly remember any other website having like static data at all. All right, so this is the one that we know, so we are just like using that. Let's see what this has, and let me just execute this part. All right, so this got executed, no error. This content variable, let's see what this has. So here it is. The content variable here has this information, and this is like a list of these dictionaries in a way, right? And let's see what this dictionary has. This has like some place ID, some license, some like a lot of information about this place, right? And this dictionary ends here. And you can see this is like more complex, but this is like a JSON file. This must be saved in a JSON file, but now we know that we can convert it to a dictionary with an attribute value pair structure and utilize it, right? So this was the whole point of showing you this API. Then again, we have this other dictionary that has like place ID, license, whatever. The good thing here is that I can exploit this information because I know that the data is saved in a certain format, right? And so that's why I can exploit this information and utilize it in my code and utilize it to extract this information and do something with it. The only thing that I need to do is like first using this URL lib, get the data, and I know that that data can be converted to like some Python object type, which is like this JSON library will help me do that. And this JSON.loads, what it did was whatever we read from that website, it converted to this like JSON type format, right? So that's like an easy demo of what's going on. Again, as I said, there are other more complex APIs that are available. And specifically this part, like many of these APIs, they go through this like authentication module where you have some like password setup. So you cannot just like directly go and access like Facebook data or Twitter data like that. You have some authentication. And so you need like extra layer of those APIs that go through that security channel and then extract data. So we're not obviously looking at that, but it's important to understand the structure of these things because they'll help you later on when you're like working on more complex projects. All right. So this was about the key value attribute value pair structure using dictionaries. And why is this important? Because most of the external data is saved in that format. All right. Um, okay, so I think that's it. One final example, and this is like a very interesting example. We have 5 minutes left, and this will utilize whatever we have looked at until now. And I'm giving you this dictionary, and I'll give you like 5 minutes to work on this. So this dictionary has like names, like strings as keys, and sets as values, right? You have to convert this to another dictionary such that I have like these values as keys and the keys as values. Just like flip it. So take 5 minutes and try to uh, do that. Like how can we flip these? And also notice that like this hiking, for example, is for both uh, this one and this one. So how can we put that in a set essentially, right? So how can we create another dictionary from this existing dictionary? So let's see if you can come up with that solution. Otherwise, if not, what I'll do is I'll post that solution on Submiti, but I'll ask you to kind of do that. We've done similar stuff many times today. Well, let's see if you can come up with this new dictionary, whatever that is. Anyone that who can give some idea of like how we can begin with that? Of course, loop through the dictionary, right? Start creating, just like pick these values. So let me just like give you a high level before you leave, right? Just like loop through this dictionary, you know how to access the values. Like for example, access the first one. And if this does not exist as a key, right, put the key of that particular iteration in the value for that, right? And if it exists, then even then add this, right? So there's a slight tweak, very similar to what we did in one of the examples, except that like you have to add, like you might be required to add two instead of one. So again, go back, check the IMDb examples. That should help you do that. And why am I asking everybody to kind of really, really do these examples yourself? Because this will be specifically helpful in the like on the homework that's coming up. So again, like today we looked at dictionaries and dictionaries of sets and how to like create one dictionary from another. Of course, dictionaries can be used as a database where we can use like attribute value pairs. And we also looked at like how to access information from public APIs, right? So that's it from my end. If you don't have any questions, that's it. Thank you so much, everybody, for joining. Please try to finish this example yourself. As I said, I'll post the solution on Submiti in like 5-10 minutes once you've tried that, right? Let me look at the questions. If me, your question is May. I'm sorry, May. Your question is homework will be due April 8th. Yeah, so like if, I don't know whether that's April 8th or not, but like 1 week from like this Thursday, essentially.